So I am recording this, but feel free to stop me if you ever have a question. I could always pause and go back and re-record. So right here we have the Pythagorean theorem. What is a theorem? It's a truth in math, all right? A theorem is a truth in math. And this truth, the Pythagorean theorem, is with regards to 90-degree triangles, right triangles. So you first have to know what a 90-degree angle looks like. It's a perfect corner, right? Usually it's denoted with a symbol like this. That's a 90-degree angle. Anything like the floor and the wall of a building, that's a perfect 90-degree angle, right? And of course, and we're talking about triangles here, so you need to actually close this off and make that a triangle, okay? Anyway, when you have a 90-degree triangle, then this will happen. A squared plus B squared equals C squared, where A and B are the shorter sides that are called legs. So this could be called side A, this could be called side B, and those are called legs. Legs. And the C value is the side opposite of the 90-degree angle. It's over there. It's a C. So this highlighted side is the C value, the C side, and that is called the hypotenuse. 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 Anyways, hopefully you guys are taking these notes down. And the truth is that if you take this side A and square it, multiply it with itself, and then add it to this side squared, right? It should equal the longest side squared. So let's take a look at the way the book introduces it. The book says, Pythagorean theorem, in a right triangle, the side opposite the right angle is called the hypotenuse. We already wrote that down. And it's always the longest. It's always the longest side of the triangle. We already know that. The other two sides are legs. So we already wrote that stuff down. And here's the Pythagorean theorem itself. It's C squared equals A squared plus B squared. I always like writing the A squared plus B squared with the C squared on this side. But you don't have to. You could have the C squared on the left side instead of the right side. Anyway, in order to use this theorem, this truth, you got to first identify which is your longest side always. And it might be confusing. Like, let's say this guy right here kind of looks like all the sides are equal, but they're not. And let's say that the 90-degree angle is right here. Well, then you know for sure that opposite of it is the C value, okay? Right there. So that's the C side, the hypotenuse, okay? So I guess we first want to be able to see and state which side of all these triangles are the longest side, which is simply going to be opposite the 90-degree angle. So right here, here's a 90-degree angle. That means that this is the longest side. This is my C side, my hypotenuse. Right here's my 90-degree angle. That means that this guy is my hypotenuse, the C value. Here's a 90-degree angle. That means that this one right here is the hypotenuse, the C. Okay. So you got to be able to identify C in order to use this theorem, A squared plus B squared equals C squared. Let's actually see how the book uses the theorem. Here's an example, or two examples straight from the book. So here's a 90-degree triangle, and the theorem says that if you do have a 90-degree triangle, then your two smaller legs, when you square them and add them together, it'll give you the longer side, the hypotenuse squared. So it's really A squared plus B squared equals C squared. They write it as C squared equals A squared plus B squared. So A is 10, so you have 10 squared. B is 24, you have 24 squared. 10 squared is 100, you could do that on the calculator. 24 squared is 100, that's 576. You could do that on the calculator, it's not 100. And then you add 100 and 576 and you get 676. Please use your calculator when you're doing this math. And at this point, you have C squared equals 676. And you don't want C squared, you want C all by itself. So if you want to get rid of a square, you got to do the opposite operation. And the opposite of a square is a square root. So what you do to one side, do to the other side. That's why over here it says square root of 676. Now, when you do the square root in an equation, you have to put a plus or minus in front of your answer, okay? So on your calculator, you're going to type in the square root of 676. You're going to hit equal. It'll give you the nice number 26. So C equals positive plus or minus 26, okay? Now, that makes sense after all. This is a quadratic equation. It has a power of 2 on there. We know that parabolas cross the x-axis most of the time at 2 locations. Those would be the x-intercepts. But then again, we're not talking about parabolas on an xy plane. We're talking about the actual measurement from here to here. And we know that measurements, they're never a negative distance. It's always positive. So because of that, you don't have to say plus or minus 26. You just say 26. Because there's no way that you measure it from here to here and say, oh yeah, that measurement is negative 26. That's impossible. Measurement is always positive. So C equals 26. That's the answer. And that's what it explains right here. The length cannot be negative, so the missing length is 26, not plus or minus 26. And they do the same thing over here. A squared plus B squared equals C squared. A squared is 7. So 7 squared. B squared is exactly B squared. And C squared is 15 squared. So you put that on the left side because they started with the C on the left side. They do the math. 15 squared on the calculator is 225. 7 squared is 49. Subtract 49 with the calculator. 225 take away 49 is 176. Then you square root and square root. And that'll give you, right here it says 13.27. And it's an approximation. Here's the reality. Let me show you on the calculator. So on a calculator, if you type in the square root of 176 on any calculator, it's going to give you this crazy irrational decimal. Any square root of a non-perfect square number is going to be a crazy decimal, okay? So if you see this on the calculator, you might have to hit this button. That's SD button. That means it changes from like fractions to decimals or decimals to fractions or square roots to decimals or radicals to decimals or decimals to square roots. So if you hit that button, it'll change it to your simplified form of the square root of 176, which is 4 square root of 11. So some textbooks, they say like, write a decimal approximation, round to the nearest hundredth. If that were the case, rounding to the nearest hundredth, well, then you would go, here's your tenths, here's your hundredth. So you would take this 6, which would change that 6 to a 7. That way you could write down your answer if they ask for a decimal approximation with that squiggly equal sign, 13.27, because the 6 changed the other 6 to a 7. So 13.27 would be the decimal approximation. And that's exactly what they wrote right here, okay? But in the quizzes assignment that I assign, I want you to leave it in simplified radical form. So you would type it in as 4 square root of 11, okay? Everybody go ahead and copy this triangle down in your notebooks, please. And we want to show how to find this missing side. So again, you have to know the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. So obviously a and b are the two smaller legs, the two smaller sides, which is 3 squared plus 4 squared equals c squared, but we don't know this value of c, so we leave it as c squared, okay? And then you do the math. It's really easy to do 3 squared, that's 9. It's really easy to do 4 squared, 4 times 4 is 16. And it's really easy to add 9 and 16, you get 25. So 25 equals c squared. I'm going to write it c squared equals 25. And you could do the square root to get rid of the square. And of course, what you do to one side, do to the other. So c equals, and when you do the square root, you have to put a plus or minus in front of your answer when you're doing, when you're solving an equation in algebra. So plus or minus 5 is the correct answer. But that's if you're talking about like a parabola that crosses the x-axis at positive 5 and negative 5. But right here, we're not talking about graphing or a parabola. We're talking about how much it measures from here to here. And again, distance is never negative, so you don't have to put the plus or minus. As a matter of fact, you shouldn't put plus or minus. All you type in is the number 5. What's that missing side? It measures 5, right? Maybe 5 inches, maybe 5 feet. I don't know. They weren't specific enough on the example. So 5 is the correct answer. Here's another. And again, you're going to set up the Pythagorean theorem. A squared plus b squared equals c squared. A is this value 4. 4 is a. So 4 squared plus b, we don't know what b is. I mean, it just says b right there. So b squared equals c squared. I know that c is the opposite of my 90-degree angle, so that's 21. So you're going to put 21 squared, okay? Now, 4 squared, that's easy. 4 times 4 is 16. I do have the plus b squared equals, now 21 squared, I don't even know what that is. So 21 to the second power on a calculator, that'll be 441. 441. Okay, so I still need to solve for b. So I need to get b by itself. I don't want the square. I don't want the plus 16. Let's get rid of the plus 16 first by subtracting 16. And what I do to one side, I do to the other side. And to be safe, I'm just going to do that on the calculator. 144 take away 16. That's 425. So what I have, I'm going to rewrite over here. B squared equals 425. Okay? And now I need to get rid of the square. How do you get rid of something? You do the opposite. The opposite of a square is a square root. So b equals, normally we would put a plus or minus, but we know we're talking about the distance, and there's no such thing as a negative distance. So I'm not even going to bother with that plus or minus. And the square root of 425 on a calculator, hit the square root button, hit 425, and that gives us, as a simplified answer, 5 square root of 17. Okay. Now that actually is the decimal value. The side would be 20.615528813 ... It continues forever. It's an irrational decimal, roughly 20.6, 20.62, right? So if they ask for a decimal approximation, yeah, you would say B is approximately 20.62. But on this assignment, I want it in reduced or simplified radical form. So you're just going to type in 5 square root of 17. You're going to type in 5, and then here's the square root button, and then 17, hit enter, and that'll be your correct answer for this missing side right here. Now, what that actually means, it's about a little more than 20 and a half, right? 20 inches, 20.62 inches from here to here. Check this one out. A lot of people are going to freak out because you don't have a nice number for this measurement. It's actually an irrational value. It's a radical. 2 square root of 10. That's what it measures from here to here. Okay. We're going to again use the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So a and b are the smaller sides, and c is the side opposite the 90-degree angle. Okay. So I'm going to call this guy my a. I'm going to call this guy my b, and we're going to find c. So instead of a squared, this is what you're going to do. You're going to put parenthesis squared, and what are we going to put in there? You're going to put 2 square root of 10. Okay. And we still have the plus b squared, and we know that b is 9. So we're going to square that, equals c squared, which we don't know yet, so we just leave it, c squared. Okay. Now, if you did this on a calculator, it's kind of confusing. Let me show you why. You see, most of us, when we try to type this in, parenthesis 2 squared root of 10, close parenthesis squared, you're gonna open a parenthesis 2 squared root of 10, and if you try to close parenthesis, it's gonna close it, but on the inside of the radical, and that just doesn't work. It's all messed up. You want it on the outside of the radical, not on the inside of that square root, right? So what you're gonna have to do is, when you type in 10, hit the side button to get outside the radical, then you could close the parenthesis, all right? So you have to hit the side button right after you type in 10 to get that parenthesis on the outside. So once again, you open up the parenthesis, you type in 2 square root 10, but then you have to hit this button to get outside of the radical. Then you could close the parenthesis. Then you could hit the power of 2, and when you hit equal down here, it'll give you the nice number 40, okay? Now, that's actually, I think, even more difficult than actually working it out by hand. Let me show you how to work it out by hand. You see, 2 square root of 10 to the second power means that you're going to multiply 2 square root of 10 times 2 square root of 10. And that really means 2 times the square root of 10 times 2 times the square root of 10, which means you can move things around. 2 times 2 times square root of 10 times square root of 10. And 2 times 2 is 4, and the square root of 10 times square root of 10 is the square root of 100, which will take you back to 10, and 4 times 10 is 40. I mean, I don't mind doing the math here, but you could use a calculator the way I showed you. Just be careful when you use a calculator. That answer is 40 right there. 2 squared root of 10 squared is 40. And then you still have the plus 9 squared. 9 squared is 81. And then equals c squared. So with the calculator or in your head, you could go 40 plus 81. That's 121 equals c squared. C squared equals 121 to get rid of a square, you do a square root, and what you do to one side, do to the other side. C equals plus or minus 11, but you know it's just going to be a positive because we only have positive values when you measure from here all the way over there, right? So your answer is 11. You just type in 11, don't type in C equals 11. It just says what's the missing side, you just say 11, right? And that'll give you full credit. So we know the Pythagorean theorem. Now we need to talk about the converse of the Pythagorean theorem. You see, we could use the Pythagorean theorem to find out missing sides of 90-degree triangles, of right triangles, but we could also use Pythagorean theorem and check the sides of a triangle to determine if it's a 90-degree triangle or not, okay? What do I mean by that? Let me start with a little story. My uncle actually owns a construction company, and one time he was building a patio in my backyard, and we were putting down the frame for the cement. And when I looked at it, we had one side like this and the other side like that. And for me, it looked like it wasn't a perfect corner. It looked like it wasn't 90 degrees. So there's a certain tool that you could put right there to check if it's a 90-degree angle. But when I asked my uncle for the tool, he's like, no, just check the 3, 4, 5. And I'm like, what do you mean 3, 4, 5? And he's like, yeah, if you just measure from here this way, 3 feet, and if you measure from here this way, 4 feet, and then you measure from this endpoint to that endpoint, that should be 5. And if it is 5, then you guarantee that that's a perfect corner. That's what my uncle showed me several years ago. And then later, when I became a teacher, I'm like, wow, he was talking about the converse of the Pythagorean theorem, 3, 4, 5, right? But that's a great way to verify that you actually have a 90-degree angle. Actually, the numbers 3, 4, 5, that is what we call a Pythagorean triple. What is a Pythagorean triple? It's a group of 3 counting numbers that satisfy the equation a squared plus b squared equals c squared. Now, what do I mean by counting numbers? Any nice number, right? They don't have to be right next to each other like 3, 4, 5. They could also be like 6, 8, 10, but they're nice numbers, right? But the deal is, if you measure, or if you have 3, 4, and a 5, that's a Pythagorean triple. You could verify that it does give you a 90-degree angle. Now, of course, in this class, how are we going to verify that? You're going to say, okay, 3 squared plus 4 squared, does it equal 5 squared? And if it does, then that's a 90-degree triangle. It's a right triangle. 3 squared, that's 9. 4 squared, that's 16, with the plus right there. 5 squared is 25. And yeah, when you add 9 and 16, that gives you 25. So 25 equals 25. You have verified that this is a 90-degree triangle, okay? That this is a perfect corner right here, 90 degrees. How are we going to ask this on quizzes and on the quiz? Here it is. A triangle has the sides 9, 15, and 12. Is it a right triangle? Well, we need to set this up. How do I set this up? I need the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. I have 3 sides right here, 1, 2, 3. If those 3 sides actually give me a true statement that a squared plus b squared equals c squared, I know that this is a 90-degree right triangle, okay? So what do I write? Tell me. 9 squared plus what? Good. 12 squared. Even though we see 15 next, don't write 15. Remember, the longest side is a hypotenuse. The longest side is a c value, so 15 squared. So we need to verify this. Does 9 squared plus 12 squared equal 15 squared? 9 squared is 81, 12 squared is 144. We are going to add those together, and that should give me, I'm going to check what 15 squared is on the calculator. 15 squared on the calculator is 225. And when I add 81 and 144, that does give me 225, and it does equal 225. I've double checked it. I could say, yes, this is a right triangle, okay? Yes, it's a right triangle. Now, so is it a right triangle? I'm going to say yes, okay? Are these sides a Pythagorean triple? All you got to do is check and see if they're nice numbers, and it worked. Well, yeah, 9, 12, and 15, those are nice numbers. Remember, the book says counting numbers. So if you count, you'll eventually get to 9, you'll eventually get to 12, you eventually get to 15. So you would also say, and yes, this is a Pythagorean triple. So if you look at your answers down here, the correct answer is this one. Yes, it's a right triangle, and yes, these numbers are a Pythagorean triple. The other options, yes, it's a right triangle, but these are not a Pythagorean triple. No, this is not a right triangle, but they are a Pythagorean triple. That doesn't even make sense, because if you do have a Pythagorean triple, it's going to be a right triangle. So this is like nonsense, this answer right here. And the last one, no, it's not a right triangle, and the numbers are not a Pythagorean triple. That makes sense. That could happen. Let's do a couple more of these. Check this one out. If a triangle has sides 5, 7, and the square root of 74, is it a right triangle? Well, we need to verify that a squared plus b squared equals c squared. So I'm going to write 5 squared plus 7 squared equals the square root of 74 squared. The square root of 74 squared. Now, some of us are freaking out right here, but you could do this on the calculator, but that's a waste of time, because we all know that the opposite of a square is a square. The opposite of a square is a square root, or the opposite of a square root is a square, which means that the square and the square root, they undo themselves. It's like me saying 74 plus 3 minus 3. It's still 74. The square and the square root, they undo themselves. So you could just scratch it out and just write equals 74. And what is 5 squared? That's 25. What is 7 squared? That's 49. And if you add 25 and 49, it really does give you a 74. So 74 does equal 74. So we've verified that, yes, this is a right triangle. But are they a Pythagorean triple? But not a Pythagorean triple. Why are they not a Pythagorean triple? Because one of the sides was not a counting number. I mean, this is a irrational number. The square root of 74 is a crazy decimal. So that's what makes it not be a Pythagorean triple. Do you guys get it? Okay. How about this one? The sides are 15, 30, and 34. So we're going to set it up. How do I set it up? Somebody help me here. What do I write? 15 squared plus 30 squared equals 34 squared. Okay, and I'm going to do all this on the calculator. 15 squared plus 34 squared equals, just on the left side, when I do all this, I actually type this in exactly the way it looks like on the calculator, and it gave me 1381, 1,381. And if I go 34 on the calculator squared, you're going to have 1,156. These guys are definitely not equal. So this is not a right triangle. Some other type of triangle, but it doesn't have a 90-degree angle in it. So you would say, no, not a right triangle. Okay. And obviously, if it's not a right triangle, this cannot have a Pythagorean triple. So this is the correct answer, that it's not a right triangle and that the numbers are not a Pythagorean triple. I hope this helps. This will be posted on YouTube and on Google Classroom.